All right, today we are going to tackle a math concept that sounds super fancy, but I promise it's actually pretty simple. It's called the closure property. And the secret to understanding it all comes down to one little rule: stay in the family. That's it. Let's see how it works. So, to get us started, I've got a question for you, and it's going to sound, well, a little weird. What in the world does making dough have to do with math? Yeah, I know, but trust me on this one, because the answer is the key to this whole thing. It all boils down to one simple, powerful rule. It doesn't matter if you're a number or a lump of dough, the rule is exactly the same. You gotta stay in the family. So, what does that actually mean when we're talking about math? Okay, so to really see this rule in action, we need a family to work with, right? So, for this explainer, our mathematical family is going to be the whole numbers. So, who's in the family? Well, just as a quick reminder, whole numbers are the ones you first learn to count with. We're talking 0, 1, 2, 3, and so on, forever. But here's the really important part: who's not invited. There are no fractions, no decimals, and definitely no negative numbers allowed in this house. Got it? All right, now that we know who's in the family, it's time to put them to the test. We're going to throw the four basic math operations at them. Addition, subtraction, multiplication, and division, and see if the whole numbers can follow that one golden rule: stay in the family. Okay, first up on the block, addition. Let's see how it does. Let's just try it out. Let's take a whole number, say 2, and add another one, like 3. What do we get? We get 5. And hey, 5 is a whole number. It stayed in the family. Cool. Let's try another one. How about 5 plus 7? That gives us 12, which is, yep, another whole number. I think I see a pattern here. And you know what? It seems like no matter which two whole numbers you add together, the answer is always going to be another whole number. So, addition, it absolutely passes the test. Big green check mark. All right, addition is in the clear. So let's move on to our next challenger, multiplication. Is it going to be the same story? Okay, let's give it a shot. 2 times 3, that gives us 6. Is 6 a whole number? You bet it is. What about 5 times 7? That's 35. And yep, 35 is a whole number too. This is looking pretty familiar, isn't it? And yeah, just like with addition, it looks like this works every single time. You multiply any two whole numbers, and the answer stays right inside the family. So multiplication passes. Awesome, we are 2 for 2. Okay, things have been going pretty smoothly so far, right? Maybe too smoothly. Let's stir the pot a little. What do you think is going to happen when we try subtraction? Is our perfect record about to be broken? Well, at first glance, everything seems fine. You take 5, you subtract 2, you get 3. 3 is a whole number, right? We're good. But what happens if we just flip those numbers around? 2 minus 5. That gives us -3. Uh-oh. Is -3 a whole number? No way. It just got kicked right out of the family. And that right there is the key. Because it doesn't work every single time, the whole thing falls apart. The rule isn't stay in the family most of the time, it's all the time. So the fact that subtraction sometimes leaves the family means it fails the test, officially. Okay, we've got one test left: division. So after what we just saw happen with subtraction, what's your gut feeling on this one? Let's check it out. 4 divided by 2. That's 2. Okay, 2 is a whole number. So far, so good. But you know what's coming, right? Let's flip it. 2 divided by 4. That gives us 0.5. And a decimal? That is definitely 100% not a member of the whole number family. So there you have it. Just like subtraction, because it only works some of the time, we can't count on it. Division breaks our stay in the family rule, and that's another fail. Okay, so we've been talking about this stay in the family rule the whole time, right? Well, now it's time for the big reveal. Let's give this idea its proper mathematical name. But before we get all technical, let's go back to that dough we talked about at the beginning. Think about it. If you take a lump of wheat flour dough and you add another lump of wheat flour dough to it, what do you get? You don't get a sandwich, you don't get rice, you just get a bigger lump of wheat flour dough. The result stays in the dough family. And that is the exact same idea we just saw with our numbers. So this whole stay in the family concept, its official name is the closure property. That's it. A set of numbers is called closed for an operation, like addition, if doing that operation on any two numbers from the set always, and I mean always, gives you an answer that's also in the same set. It's just the fancy math term for our simple little rule. All right, so we've run all our tests, we've learned the official name. So what's the bottom line? What did we actually figure out about our family of whole numbers? Well, this table right here sums it up perfectly. For the set of whole numbers, we can say it's closed under addition and multiplication. The family stays together. But it is not closed under subtraction and division because those two operations sometimes create outsiders, answers that are just not part of the family. So we've gone through the whole idea, but the best way to really get something to stick in your brain is to try it yourself. So now, it's your turn to do some thinking. So here is your homework challenge. We used that dough analogy to help explain addition. My question for you is, can you come up with a real-life example that shows how the closure property works for multiplication? Think about it. What's a set of things where if you multiply them, the result always stays in that same category? Give it some thought. Thanks so much for joining me today.